Thank you, everyone. I think you can put the slides up. So this is a topic that I'll be embarking on today, which is pretty much unleashing the power of AI in a 5G enterprise suite. It's my tool. Cool, thanks. So just a brief overview about myself. So I'm a principal data scientist at Vodacom. So we are pretty much the evangelists for our African opcos. So our job is pretty much to make AI a reality in our opcos, so the likes of Tanzania, Mozambique, Lesotho, DRC, Egypt, and so on. So yeah, so what I'm going to do today is pretty much attempt to give you a low-level view of what it feels to implement artificial intelligence or build these models that everyone's been talking about today. And I really hope you're not experiencing AI fatigue today because everyone's been talking about AI. Maybe I should just call it the thing, instead of AI. But yeah, so pretty much what my presentation entails is the evolution of telco and AI. What does the power of 5G unlock? Where we should be as an industry, how to make AI reality, and what it takes to be an AI-alive company or organization, right? So we're pretty much over, or we're past the time where we need to be AI ready, right? That's an old term. So if you're still not AI alive, I think maybe, hopefully this presentation will help, right? Okay, next, okay, cool. So just for the purists and those that are really passionate about the history of AI and low-level design, those will probably be engineers and computer scientists and so on. But yeah, AI pretty much started when, in the 1950s, where the power, we first had the first few computers, and the compute power wasn't really that great, but a few efforts were made focusing on rule-based systems and first few attempts of machine learning, pretty much rule-based, logic gates, if that rings a bell for some people. And yeah, then in the 1980s, this further expanded into people putting some efforts in building expert systems, which are pretty much, again, AI attempts or attempts to building intelligence systems, which are still rule-based. So think of this as really complex rules or many combination of business rules that people build to try to mimic human behavior. And then we also had Frank Rosenblatt, who introduced the perceptron, which is pretty much the feed-forward neural network. And those are the pretty much major developments of artificial intelligence. And then we then saw, okay, in the same time range, we saw people really making efforts to analyze large data sets, building insights, trying to extract valuable information from the data, and identifying patterns and trends, building machine learning models that can predict some variables, right? So hopefully I've seen a lot of people are still stuck there. A lot of companies are stuck there and are pretty much struggling to move to the next phase, which is pretty much taking advantage of AI, or even traditional, I'm not talking Gen AI, I'm talking traditional machine learning, right? Your logistic regressions, your XGBoost, there's still people that really don't know what that means. And then we're currently in an era where we've seen the power of natural language processing. I think a lot of people spoke about it extensively. And I like the fact that Kenneth spoke about IoT, which speaks to now edge AI, right? So edge AI is pretty much people where we build models that are on a device. So it's not a model that's sitting on a data center somewhere. So you have models running on your watch, on your phone. They pretty much train your model on your device and make predictions in real time on your devices. So that's pretty much where we are, and what we also in an era where I think I've got the wrong slides there. But yeah, we're in an era where we're pretty much doing machine teaching, right? So we're teaching machines how to learn. So we're giving them tons of data specific to certain domains, and we asking these machines to learn, and then we query or ask them questions about our data. So some of you might have heard of the concepts of RAG and so on. This thing's a bit wonky. Okay. Cool. Right. So you may ask yourself, okay, what does it take, right? So I'm just going to highlight or show you the different types of levels of digital maturity, right? So you have companies that are beginners, pretty much companies that don't really have a good digital footprint in the organization, and then you have the conservatives, which are the intermediate companies that are really developing some level of digital capability, but they might have disparate systems that are not really fully integrated. And then you have advanced, which are the fashionistas on my slide there, that are very well established, but don't really take full advantage of the technology. And then you get the mature guys, which are the digiratis. These are companies that are fully digitally transformed, and they're pretty much market leaders when it comes to tech or AI. Okay, not sure what's going on. Okay, cool. So this slide just gives a view of the AI footprint in the continent. These companies are mostly startups, but this really just gives a view of companies that are AI ready, right? Or that are able to build AI use cases. So in South Africa, this is a pretty much old slide, but 726 companies are mostly startups, which is very little in my view, right? And then, as you can see at the bottom, DRC 10, but what this speaks of is an opportunity, right? I'm seeing an opportunity in that gap there, right? So yeah, a lot of startups will probably make a lot of money, right, by taking advantage of these opportunities and helping these companies that are not really capable of delivering AI solutions. And we should see the graph get better over time. Okay, where's the receiver? I'm not sure what's going on. Okay, so here I have a small video that pretty much shows what the power of 5G can do and where we should be as an industry. Makhosi spoke about real-time recommendations, right? Getting recommendational predictions in the moment. Imagine if you're sitting in the Gautrain and you just get relevant recommendations, right? Your phone, something pops up on your phone saying, you're watching some series on Netflix yesterday, do you want to continue watching it? And we'll give you a discounted bundle, and so on and so on, right? So that's the reality that we should be enabling as telcos, and that'll pretty much change the lives of our customers and their lifestyle choices. So let's take a look.
Real-time data means when you are delivering data insights to users and customers as they happen. You're processing events to just continuously crunch numbers and provide online insights.
Let's think about some household examples. We all use Google Maps, right? And Google Maps gives us updates about traffic, about lots of different things. That makes us able to take better decisions based on the knowledge that we have available. So how is that done? Using real-time data. Other examples would be ATMs, fraud detection, customer service. Why? Because we want to have up to the minute, up to the second information to help us make better decisions.
If you're talking to folks that do more kind of embedded hardware, that might be something that's millisecond real time, whereas kind of a lot of the analytics, business insights can be within a couple of minutes. That still might be real time.
It's really challenging to deal with. There's a lot of data coming from a lot of systems. We're generating more data than we ever have before, and we're trying to do analytics on it to make smart decisions, usually business decisions or product decisions. And so every company is becoming a data company.
So how is it done? With different technologies that use real-time data, differentiated from batch processing. Batch processing meaning I collect a bunch of data, I wait, and then I send it over. Real-time data, as it suggests, is moving in real time.
My PhD was actually focusing on real-time data. In that case, we needed to have a real-time data connection for human brain images. If you are doing real-time data with algorithms sitting on top, you have to be really focused around finding efficient ways to process signals in real time and to know exactly which of those signals you're going to prioritize, because there's a weight trade-off between what it is that you can track, hold, store, and evaluate in that really, really short time period and the outcome that you're intending to receive. So it's a really interesting space to be in if you want to look at algorithmic efficiency specifically.
The main thing is understanding that it helps us make better decisions by having better information in real time.
Cool. So isn't that awesome? So imagine, like what Sal mentioned there, getting real-time data. Imagine if you can get robots performing an operation on a person, right? Or analyzing brain signals and so on. So in real time. So that could all be realized by what Kenneth and them are talking about, IoT, once we get to a mature level where that their systems work properly and we're able to take advantage of that, and that would be great. So yeah, you may ask yourself, where do we start? How do I get there? How do I get to the end goal, right? Next slide. Thank you. So it's important to get use cases, right? So we've seen a lot of, in a lot of industries, people invest a lot in the platforms, the tech, with no idea, right? So they hope that somewhere, somehow, they'll be able to utilize their platforms. But yeah, so people invest a lot in cloud technology. I've seen people make investments on cloud just to move data. And I'm like, after that, what happens, right? So use cases are non-negotiable, right? So what this means is sitting with your domain experts in your company, coming up with ideas on how to use the thing, AI, to come up with good use cases. You can use AI to really enhance existing use cases, right? So a lot of companies use traditional CVM methods, slice and dice the data, do analytics, come up with rules, and hope for the best, right? So, but there's another level. So what I'm talking about now addresses the product recommendations and custom interactions portion, use cases, right? So there's something called the segment of one, right? So traditional CVM guys will tell you that, I have the segment, right? I've done this cool segmentation. That's old information, right? So every person is unique, right? So we're at a point where we can recommend products and services that are unique to an individual, right? So the difference is, in a cluster of customers, you have people that are still unique, that are still different. So you can't give them the same thing, right? That's why your conversion is low, right? Some people in that cluster won't buy. Like, I don't like this product. So machine learning, we've seen a lot of strides. People have been talking about hyper-personalization. That's what they mean, right? And then we can use machine learning, A/B testing in marketing, coming up with knowing what's the right campaign strategy to use, or knowing what's the right image or for your billboard or your TV ad, right? So just testing different strategies using machine learning, and that'll save you a lot of time, by the way. So yeah, we've seen efforts in fraud detection, cost saving, a lot of cost saving that happens there, process optimizations. They've spoken a lot, I think, about network optimization. And yeah, so, right, you have your use cases now, right? So what do? Do you have the stack? Do you have the science, right? So what it means is you have the right technology to build these machine learning use cases, right? Do you have the right people with the right skills to build these models? But it doesn't end there, right? So one link that I've seen that's missing is you have a lot of data scientists, right? That, or your smart people, data analysts that are there, but they don't really understand the business, right? So they won't be able to deliver these use cases. So if you don't have your domain experts sitting with your data scientists to come up with really cool solutions that add value to your business, you're just going to have people sitting there crunching numbers and wasting time, right? So that's a very important aspect. Have use cases that add business value, trial them on a small scale, I'll address that. And then once they work, once they know, you know they're working, scale them up, right? That's when you can do your nice investments and ensure that you're getting a good return. So who do you choose as your co-creators, right? So you've got the platform, or maybe on a small scale, you have the use cases with a few data scientists or a few clever people. How do you choose, or how do you extend your team, right? So the data analysts and data scientists are pretty much what I deem as your evangelists, right? So they'll go there, let's say, so we work with African OpCos a lot. The data scientists and data analysts sit with the people in market, understand the pain points, their issues, and then they come up with the ideas. So they pretty much translate your business requirements into technical requirements from a data science perspective, right? So, and then that's where you run POCs. Once you're done with that, that's where you need these two people at the bottom, right? Your data engineers, your ML engineer, provided you have the platform, right? And they will take these, maintain them, deploy them, and ensure that they run successfully, make the correct predictions, give you the right business value, right? Okay, yeah, and so this is just an example of how a decent platform should look like, or an ML platform should look like, right? So this is, in our world, this is what we do, right? So the data engineers will do the first leg of the part, the feature engineering and data ingestions, and so everything data. Model deployment, those are your ML engineers. They will pretty much build your weights as model development and model deployment. And then, yeah, but the data scientists build the brains in the middle then. Okay. Next. Okay. Yeah, so this is pretty much my last slide. So when you have use cases, right? So test your use cases before you make any dramatic or drastic investments, rather. And then test your use cases on a smaller scale, measure the performance. Once you're happy with that, your stakeholders are happy, then you deploy your use cases, right? So that's pretty much how the life cycle in the world of a data scientist or data science that adds value to your business looks like. So, yeah, thank you.